Okay, hey, this is Daryl at Inda-Gro, and for anybody that's going to be buying these systems, these are our main sensor controllers. And what I have here is the main sensor. As you can see, it's a standalone box. It's designed to mount at the top of a greenhouse. And if this were a greenhouse and there's some type of structural member, you simply attach it to anything or move out some more structural to get it to where it has an unobstructed view of the sunlight. On this is
that'd be inside underneath the canopy.
Correct. You don't want to put it outside because what you want to do is measure the amount of sun coming into the greenhouse at the apex. And this has a run switch and a test on switch. We're going to have it in test on because in test on it will activate in 5 seconds or 10 seconds. The runs position will be 5 minutes. So that means you'll have a sustained condition for 5 minutes before this switch activates the panel. Which this panel right here would be typical of what you'd see in a greenhouse. This one happens to be 3-phase, and there's a lighting contactor here which will control all the breakers. Now, this sensor communicates via an RJ45 Ethernet port.
Sometimes, real quick, in some greenhouses you'll see a sub-panel box, a relay box, and then that product will be connected to the relay box.
For the lighting.
For the lighting.
This is only lighting.
Only lighting.
So an RJ45 connector is installed on the panel housing, and you'll have to run a Cat6 cable to wherever this ends up going. It plugs into the side of the panel. You just drill that in and plug it in, and then at the this now becomes sunlight right here. Okay, so let me go ahead and plug this in. And this is all you have to do. There's no other power supplies. Get your Cat6 over here.
Let's say you have a blackout material. You can also hook this up to your relay for your blackout material. So when the sun goes down, this is shutting off the lights, and it's activating like the last the device that automatically rolls out the shades or the blackout
absolutely.
materials.
Because in addition to turning on the lights, what you have is a relay that's built into what we call the panel assembly. So the main sensor controller consists of that sensor and this panel assembly. And the panel assembly comes pre-wired with the Cat6 cable on it. And as you can see in the panel, there's one of your panel assemblies. The Cat6 plugs into that coupler, which picks up the outside connection. And then this is my solid state relay. So there's really nothing you have to do inside on the low voltage side of this thing. You have to get power to this, which is done here, and you have to open and close the coil that runs this relay. Very simple stuff.
Very simple
This
stuff.
relay runs all of these breakers. So this is a very typical application. All right, I'm going to take my sunlight levels here now and create a condition where the supplemental lights would have to come on. So I'm going to lower my sunlight values and watch this red light will become green. Okay, and in 10 seconds, my greenhouse lights are going to come on. Okay, so there we are. My greenhouse lights are running. And this can control as many fixtures as the main incoming power is capable of delivering. Okay, so virtually unlimited. All right, on top of the greenhouse lights, this is called our Daylight Harvester series. It has a sensor, and that sensor is designed, especially a very large greenhouse where light levels will vary, it's designed to lower the light levels to account for available sunlight down here. So if I have a situation where I have maybe only 50% of the light level needed, then it's going to react accordingly. The plants are still going to see full light levels because it's going to be a combination of sun and artificial light. But this just knocked my connected loads down. I'll show you on my watt meter here.
You go around.
Hang on, go around. Say we're drawing 114 volts, 113.93 power factor, 60 hertz, and we're at 156 watts. Now the wattage is going to go up as it warms up. So it just started, it's going to be relatively low. That's going to come up to over 400 watts as it runs. Okay, but to let you know, relatively speaking, we're going to drop it down in half. See that?
Wow.
So you'll go from 420 watts at full operating output to 210.
Wow.
Instantly, guys. And it's also step dimming. So as I have variations in the sunlight intensity, it's not just going to go high-low, it's going to go in between, see?
Wow. That's amazing.
Getting that?
Oh yeah.
So just a great way to save energy and still meet crop DLI. So you see we're still climbing, and again, that'll about 5 minutes, that'll fully top out at 420 watts.
420 watts. And then you're talking also about the LEDs?
These are called the pontoons. It's an accessory. And for flowering plants, these are asymmetrical diodes designed to give us...
so cucumbers, tomatoes, things with fruit, things that have not just a vegetative state but a flowering state as well.
Correct. Not necessary for the enhanced development of cash crops or fruiting crops, but what it will do is increase flowering sites and increase sizes and decrease times to harvest on a lot of the plants.
Decrease times to harvest.
Yeah, so what we'll do is we'll turn those on here, and as you can see, the diodes are laid out asymmetrically so that they interlace. And the nice thing about that is if my canopy is typically 20 inches away, that's drilling down and finding any spot in the canopy to enhance flowering development. The outside plane is designed to work in concert with the adjacent fixture. So another fixture spaced at 36 or 48 inches on center is enhanced by this plane as much as it is enhanced by the plane on the other fixture. And then we have forward throw diodes here. What happens at lights out though is we're going to simulate darkness with just these. Okay, now I just turned the power off to the pontoons and you can see there are some diodes that aren't running right now. Alright, and those diodes, there's absolutely no power to anything, are running off of lithium-ion batteries. And that's our lights out or sunset spectrum diode, which is a 730 nanometer wavelength, which triggers the phytochrome or flowering response indoors. Very important that you get that with an indoor grow because otherwise you give up 2 hours for the plants to relax into that phytochrome.
So this last bit of LEDs that is run off a lithium battery, that gives it the last bit of sunset that it needs, that normally if you're blacking out when the daytime's still going on, that last bit of just a little bit of 5 minutes or so of...
5 minutes, exactly. And then it steps dim down from the 730s on, which is a very dull red to the eye because it's almost outside our visual spectra. But to a plant, it's the mother's milk. It's the signal, hey, take advantage of it, it's dark, time to flower.
Time to flower, and it speeds that up, and the plants then start to grow 2 hours earlier.
Correct. You can push your flowering period harder. Wow. Maybe instead of a 12-12, run a 13-11. More photosynthesis, more photons to sugar. So you're really trying to mimic the outdoor photo period for the genetics that you're growing.
That is amazing.
So where are we at right now? Let's go up.
And then did you want to show me this over here, or do you want to keep that out?
Sure. Ultimately what we're doing is developing a microprocessor control. This will be called our ADR. And what this will do is be an accessory to everything we're showing here, where you can cume the daily photon counts off of the meter, the main sensor that is. And if you have an established value such as 30 moles per day, and the main sensors realize that, then this is designed to open that circuit and not let the lights run at all.
It also measures everything, right?
It will give you a historical database for the past year, for example. If you had values in March of 2012 and you want to repeat those values in March of 2013, then you can do so. Increase it or decrease it based on your crop production values.
A golden nugget that one of my mentors once told me was, if you can't measure it, you can't manage it.
And I cannot agree more. So this is a way of taking advantage of a lot of the characteristics in lighting that is ignored in the greenhouse, and that is, what's your instantaneous micromole reading, what is your daily or past daily moles per day values, and it'll also interface with the utilities, where they have demand response programs that can help lower your utility rates under agreements with the utility when you have over 300 lights. They generally look at 300 kilowatts and more to be accessible to those programs. But this is written in a code that the utilities recognize, and if you're on one of those programs, they'll discount your utility rates by 30% in some cases.
Wow.
Yeah.
This looks like an amazing product. We look forward to it coming onto the market. Thank you so much,
well,
Daryl.
Everything's on the market with the exception of the ADR,
yeah.
But that'll be ready here in the next couple of weeks, I'm sure.
All right, look forward to it.
Okay,
thank you again.
Thanks for stopping by, Mark.
Yep.